So where do we have a bridge? You think there's a lake or something and you want to connect two land areas on the banks of the river or the banks of the lake. We cannot walk through water. So on top of that, we will be connecting or we will be having a bridge. So bridge is nothing but it is a connection between 2 points. The same meaning applies here also. The term is what is a meter bridge? Length is measured using the SI unit of meter. So what is a meter bridge? Is this something new or something if you concentrate? This works on the principle of Wheatstone's bridge. You should remember what we learned in Kirchhoff's laws. Kirchhoff's first law, second law when we did a derivation. Wheatstone's bridge, which consists of 4 resistors connected in the form of a quadrilateral. So there, 2 ends, you will have a battery source connected and across 2 ends, galvanometer will be connected. So that connection is called as your Wheatstone's bridge. So this meter bridge works on that principle. How we connect 4 resistors in the form of a quadrilateral, the same way here we will be connecting wires. So one more question for you. What is the principle of meter bridge means? Your answer will be it works on the principle of Wheatstone's bridge, or you can tell Wheatstone's network. So you see here I have a connection. This is your second practical experiment what we do. Using this meter bridge, we are going to do 2 experiments. One is to find resistivity. The second one, we have to verify Ohm's law. So for both, you have metallic pieces here. You can see L-shaped, 2 structures connected to the end. And in middle, you have a metallic plate. So this setup will be on a wooden board. So what is meter bridge is depicted for you here. You have 2 L-shaped metallic plates denoted by A and B at both the ends. Now you see the connections what are made. For these ends A and B, the green line what you can see is connected to a battery and a plug key. Plug key is just to have as a protection for the circuit. You'll have one key. If you put it inside, it will be closed. If you pull it outside, the plug key remains open. It's only for connection. So keep this clear. Across the ends A and B, you have a plug key and a battery connected. See, there are 2 gaps here. One is called as the right gap. The second one is called as the left gap. So across my left hand side, RB is nothing but resistance box. So here green color denotes the wires. So in your left gap, you're going to connect the resistance box. Resistance box can have numbers from 0 to 100 or 0 to 500 ohms or 0 to 1000 ohms. Like that, you can vary the resistance. This is your resistance box. And in your right gap, you can see we are connecting a wire. Resistance of this wire is unknown. Let me explain again. 2 terminals A and B, you're connecting a wire to a battery. In your left gap, resistance box, which can change, which can vary from 0 to 500, whatever value you want to give. In your right gap, you should connect a wire. Wire also is a conductor. It can allow current to pass through. So it will also have some resistance that is unknown. That's why we denote it with the symbol X. There's only one thing left at the middle. So that is connected to a galvanometer. G denotes your galvanometer. Galvanometer is a device used to detect the presence of current. And the other end of the galvanometer, you can see an arrow mark here. That is nothing but it is connected to a jockey. Jockey is I can use this and slide it on my wire. I can move on my wire using this jockey. As I move, deflections will be seen in the galvanometer. So this setup is called as a meter bridge. I'm repeating it again. 2 metallic L-shaped frames. Across 2 ends, we have a battery connected. Left gap, resistance box is connected. Right gap, wire of unknown resistance is connected. Through the middle point, I have a galvanometer, which in turn is connected to my sliding jockey. Sliding jockey means I can use that and move it on my wire AB. Now, how we are going to do the experiment is, after giving all your connections, the plug key should be closed, meaning current will flow. You switch on the circuit. Now, when I keep this jockey, at the end A, galvanometer should show opposite side deflection. That is, when I keep it at A, this galvanometer should move towards B. Galvanometer will have readings like center you will have 0, right hand side 30 readings will be there, left hand side 30 readings will be there. So when you keep it at A, opposite side it should come to 30. When you keep it to B, towards A, that side the galvanometer needle should move to 30 degrees. That means our connection is correct. So how to check the connections are correct is the galvanometer, when placed at the points A and B, the sliding jockey, should show opposite full side deflection. So when you keep it at A, deflection should be seen towards B. When you keep it at B, deflection in the galvanometer needle should be shown towards A. The needle will move. After checking that, from the resistance box, I will remove out resistance of my choice, R value. Say I'm going to remove 1 ohm. So when I take out that 1 ohm, I can take this jockey, keep it at A. So you know clearly, when I place it at A, towards my B side, it will remain at 30 degrees. So slowly you have to move it. As you keep moving from 30, it will come near to 0, that is towards the middle. So as you keep moving, you will get a point J where galvanometer will show 0. That means no current is passing. So that point is called as the balancing point. Keep it in mind, you should take your jockey, keep moving it. Galvanometer should show 0 deflection. That point you should note down as J. Distance from A to J will be denoted with the symbol small l, which is called as balancing length in centimeter. This distance is from A to J. What point is J is when the galvanometer shows 0 deflection. Now the whole length of the wire is 100. Since from A to J it is L, from J to B, the distance will be 100 minus L centimeter. Second trial. First time in the resistance box, I took out 1 ohm. Second time, you should take out 2 ohms. Repeat the same. Keep it at A, keep moving it. You will get a point J where galvanometer shows 0. The distance from A to J will be L. From J to B, it will be 100 minus L. Third trial, you'll remove out 3 ohms. Like that, for different resistances, we will be finding out the different balancing lengths. So when you calculate this, read this point, when the galvanometer current is made 0, that is, there is no deflection seen in the galvanometer, or this needle should point 0 by adjusting the jockey. Jockey is the thing what you slide over. Position on the meter bridge wire for the given values of known and unknown resistances will be calculated. So how to get the value for R here? X is the unknown resistance, R is the resistance what you take. So your formula will be X is equal to R into 100 minus L divided by L. So you can use this formula, or there's one more formula like X is equal to S into L divided by 100 minus L. You can use that formula also and find out what is the value for X. I'm repeating the formula again. You can just make a note of it. X is equal to R into small l divided by 100 minus L, and that will be in ohms. Some textbooks refer this as S. So you can write your formula as X is equal to S into L divided by 100 minus L centimeters. So this is regarding your meter bridge experiment. So to tell it again, you do all your electrical connections, check if the circuit is correct, place the jockey at A, it should show opposite full scale deflection. Same way at B. To start your experiment, remove some resistance, say 1 ohm. Keep the jockey sliding. You will get a point J where galvanometer shows 0 deflection. A to J, on the scale how you measure centimeters, same way you can measure the length as L centimeters. J to B, the length will be 100 minus L. Resistance will be calculated using the formula X is equal to R into L divided by 100 minus L centimeters. So that is related to your meter bridge and what is meter bridge experiment. If the same meter bridge is extended, so you can see here, you have only one wire from A to B. A to B is a wire. If I connect 2 or 3 wires, then we get a potentiometer. So what is a potentiometer is, you can see here, between A and B, the wire is moving in first line you have from here to here. This is 100 value. Again, I move in the opposite direction. This becomes 200. Again, I move here. This becomes 300. And here it is 400. What are these numbers is, if the resistance wire is considered only from A till this point, then the value of the resistance will be 100 ohms. If you consider from A till this point, then the resistance will become 200. From here to here, if you consider, it can offer a resistance up to 300 ohms. Between A and B, the total wire, if you take into account, the resistance offered can be 400. Now, when I'm doing any experiment, I want less value of current. Means I will move my jockey only from A till the point where it shows 100. If I want higher value, I can move it on the point near B. So how much we want, there I can press the jockey and get the resistances. So from A to this point is 100. From A to this point is 200. From A to this point is 300. From A to B, your point will be equal to 400 resistances. So if wire of longer length is there, then we can use a potentiometer. If only one piece of wire is given on a meter bridge, then we call the term or the device to be a meter bridge. Now, why is meter bridge used means, you can find out what is the unknown resistance. What is the use of potentiometer in the sense? Potentiometer is a device to study or to compare your EMF. EMF is electromotive force. Imagine there are two cells. I want to know what is the ratio of the EMF. I cannot do it using a meter bridge, so we use a potentiometer. So potentiometer is a device to study the EMF of two or more cells. Let's look at the diagram. Across the terminals A and B, I'm going to connect a battery. See, there are two terminals, two positive, two negative. So I'm not using the word cell. I'm using the word battery. Below that, A is written. A is called as an ammeter. It will have two terminals, positive and negative. Ammeter's work is to measure current. The next device is RH. RH is nothing but rheostat. Rheostat again can supply current. See, you have one green line here. It will be like a small sliding thing. You keep moving it, current can be passed. So E denotes my battery, A denotes my ammeter, RH denotes my rheostat. And the small two terminal K, what you can see is plug key. I'm going to do a series connection here. So end to end. A and B is your potentiometer wire. E is the battery. A is your ammeter. RH is your rheostat. And K is your plug key. We'll connect it in a series way. Can you see? The connection in green is given. So this setup now is the general setup for your potentiometer. My aim is to compare the EMF of two cells. So I'll connect the two cells now. Observe carefully. I'm connecting one V here. V is your voltmeter. Across A, voltmeter will be connected with positive and negative. What is this point J here? We call it as the balancing point. That is, the reading should show to be equal to 0. That point is called as your balancing length. And distance from A to J will be denoted with the symbol L centimeters. And you can see how current is going to flow. It will start from the positive, from A move towards 100, from there move to 200, from here to 300, back again to 400. From your plug key, it can go up. So this is the direction of the flow of your current. What is the principle of this potentiometer is V equals IR. What law is it? It is your Ohm's law. V is the potential difference, I is your current, and R is your resistance. Now this resistance can be termed or written in terms of rho. Rho is your resistivity, that is resistance per unit length. L will be the length of the wire. A will be the area of cross section. So we have a formula for R. R is equal to rho into L divided by A. So this formula will become V is equal to I rho L divided by A. If the constant current flows through the potentiometer wire of uniform cross-sectional area capital A and uniform composition of material rho, then V can be written as this whole thing is considered as a constant K into I. Or you can write V is proportional to I. That is, potential is proportional to current. This is the principle of your potentiometer. What is the principle of meter bridge? It is your Wheatstone's network. Principle of your potentiometer is Ohm's law. Mathematically, we write it as V is equal to IR, or you can write V is proportional to I. Or you can keep K as it is, bring down I, we'll write V by I is a constant. That is, potential difference across any length of the wire of uniform cross section and uniform composition will be proportional to the length when constant current flows through it. So what is potentiometer? One word answer: device which can study the EMF. What are its uses? It is used to compare the EMF of two or more cells. What is its principle? It works on the principle of Ohm's law. That is, V is equal to IR, or V is proportional to I, or V by I is a constant. So this is the principle, and this is your schematic diagram. If you plot a graph taking I and V, I is current along x-axis, V is the potential along y-axis, you will get a straight linear graph, meaning to say, as current increases, potential also will increase. It is a linear graph what we will get. So now to compare, that is the potentiometer setup. If I'm going to compare it, see the same diagram what you had here. Observe carefully, I'm connecting two cells now. The first cell is E1. See the difference? E here is a battery. Two cells are connected. This is only one single cell. Plus is the bigger line, minus is the smaller line denoted in red. Red is positive, black is negative. So this first cell, I'm connecting it across A. RB is a resistance box. G will be my galvanometer, and it is getting connected to the point J1. Observe carefully. I'm not connecting it between A and B. Resistance is between 100 and 200. So first cell is connected to the point A, to a resistance box, from the resistance box to the galvanometer, from the galvanometer to the sliding point. Now jockey here by J1, galvanometer when I place it here is showing 0. Current through the galvanometer is 0. That means no current is produced. That's the first point. Now see, I'm connecting the second cell. Current here will be denoted as I1 for you. Second cell is E2. So again, I'm connecting it to the point A. You can see the dotted lines here. So again, through the resistance box to the galvanometer, but the jockey point is J2, that is between A and the point 100. So what you should keep in mind here is, first cell is connected between 100 and 200 for the balancing point. Second cell is connected between A and 100 for the balancing point J2. Now when you do this, balancing point is obtained for a cell when the potential at a point on the potentiometer wire is equal to and opposite to the EMF of the cell. So this balancing point, meter bridge, we found out what is the length. But here it will be equal and opposite to the EMF. J1 and J2 will denote your EMF. So you have the formula E1 is equal to V into A and J1 for the first cell. This V is equal to I into R. But what is R? Rho L by A. But L here is L1 because we are taking for the first length. So this B is equal to IR is your Ohm's law. Instead of R, you're going to use rho L1 divided by A. Same way for the second one. E2 will be equal to V, A as it is. Balancing point will be J2. So when you take J2, this will be again equal to I rho L2 divided by A. So all common terms will cancel. I and I will cancel. Rho and rho will cancel. A and A also will cancel. So what we will get? E1 divided by E2 can be equal to L1 divided by L2. So this is the balancing condition for your potentiometer, or you can get the EMF of the first cell and second cell by taking the ratio of L1 and L2. This is how a potentiometer works. This is also one experiment for you. So to do the connections, this wire will be on a board, on a wooden board. Two ends will be there. One you will connect to the battery. From battery, one terminal will go to the negative of your ammeter. From negative of the ammeter, positive of the ammeter wire will get connected to the rheostat. From rheostat to the plug key. From plug key to the point B. For the point A, two cells we will connect. See, one can be a dry cell. What red color cell what we use. You can take another cell like a Leclanchier cell or any other cell what we can compare to study. Or it can be an ordinary battery or the common cell what we use in the experiments also. So you will connect both the positive terminals to A. Negative for both should go to a resistance box. From the resistance box it will go to a galvanometer. Now when you do the first connection, you have to take the jockey and slide it. Where galvanometer shows 0, that point will be noted as J1. Then connect the second cell, take the jockey and slide it. If galvanometer is showing 0, that point will be taken as J2. From A to J1, that distance is L1. From A to J2, that distance will be denoted by L2. You just take the ratio. E1 by E2 will be equal to L1 divided by L2. This is from the formula. The potential is equal to the balancing length in this condition. So that is the potentiometer. The balance point will not be obtained on the potentiometer wire if the fall of potential of the potentiometer wire is less than the EMF of the cell. Now normally the cell what we use, the red color cell, its EMF is 1.2. If you take a battery source, normally we take an EMF of 2 volt. The length should be greater than that. If the length is lesser, we will not get our output. See, this one word I want you to remember. Working on the potentiometer is depending on null deflection method. Mathematics, you just remember. What is a null set? I want Kavishri to answer. Null set. What is a null set in maths?
Ma'am, it is 0, ma'am.
0. Elements will be 0. Very good. Nancy, give me an example for null set. Nancy, example for null set. Sandhya, give me an example for null set, or how do you denote a null set in maths? Share. Yes. Null set. What is null set also called? Little louder if you can tell. Sharon. Sharon Blessy. Steffi. What is a null set? Steffi P. Okay, I'll add up points for those who are answering now. Anybody who knows the answer can unmute and tell me what is a null set.
Ma'am, a null set is also called as an empty set, ma'am, which has no.
Very good. May I know who's answering?
It is an empty set, ma'am.
You're correct. You're correct. But your name is given as Micromax. I want to know who it is.
Ma'am, myself, Vinu, ma'am.
Vinu. Very good. So null set is an empty set which has no elements. Very good. Perfect answer. So here potentiometer also, we are going to do it with the null deflection method. What is the meaning? Galvanometer should not show any deflection. It should show 0 deflection. Null set, she told it clearly. Null means empty. So here also null set or null deflection means when galvanometer shows 0, we denote the balancing point. So what is the principle of potentiometer? One word, Ohm's law, or you can write null deflection method. So the resistance of the wire will become infinite. Hence, potentiometer can be regarded as an ideal voltmeter. It's a 2-mark question. Why potentiometer is called as an ideal voltmeter? One reason, it follows null deflection method. Hence, the resistance of the wire will become infinite, or it will be infinity. Infinity means we cannot measure. So that setup can become an voltmeter. That is the meaning for why potentiometer can be used as a voltmeter. I want to quickly revise 3 devices for you. Galvanometer is a device used to measure or detect the presence of current. Galvanometer denoted by G. Ammeter is denoted by the symbol A. It is again used to measure current. Voltmeter is a device to measure your voltage, and that will be denoted by V. I'm repeating: G galvanometer, A ammeter, V is voltmeter. Galvanometer and ammeter to measure current, V to measure your voltage. And one positive negative will become a cell. A combination will become a battery, which is needed for you. Okay. So with this, your current electricity chapter long answers gets over. So I think we can go for 1 and 2 mark questions for tomorrow's class. I will unmute you. If you have any doubts, you can ask.